Okay, so this is 7475, and what we're going to be doing is answering the questions on your Chapter 7 practice test, and we're finding geometric mean. Remember, geometric mean is where I multiply two numbers together and find their square root. That gives me my geometric mean. So when I take 9 times 16 to find my geometric mean, I find that this is 144, and the square root of that is 12. So x is 12 there. In 22, I got to keep in mind, not all of these will be perfect squares like 21 was. Sometimes I got to factor them. So I'm still doing the geometric mean. It means the square root of the product of two numbers. And I could come up with 400 there. Okay, but when I look at that, 400 is 16 times 25. So that is a nice perfect square there. Okay, and so 400 is going to give me that 16 times 25. So that's going to be a square root of 400, which is also 20. Okay. My last one's not real nice. I've got x is equal to the square root of 8 times 32. I get 8 times 32, and that's 256. Now this is equal to the square root of 256, and that is a perfect square of 16. Okay. Now, in this next one, I'm looking at my choices here. I have my choices, and remember, these are my possible plays when I'm looking this over. So if I have this drawn out, and we'll fix this up a little bit. S1, S2, A, L1, L2, and this whole big thing is H. Okay, so those are my options. And now when I look at this, next one, I'm going to take these down so they're out of my way. I'm going to find X, and finding X, that's leg. Okay, so using leg, finding leg, I'm going to use one of these two. Okay, since it's going to be leg 1, I'm going to use the first one. So I've got H, L1, L1, S1. H is 5, L1 is X, and S1 is 1. So this is 5 is equal to X squared. And then remember, I've got to take the square root of both sides when we're looking that over. So I'm just moving my stuff down, and I got the square root of 5 is equal to X. Now, that's finding X. When I find Y, which is the altitude, I have S1, A, S2. And here's Y. I'm looking these over. That's my S1. This is my AL2. That's my L1. And this is S2. So this one has, I got blue, my S1, my S2, and my A. So I've got S1 was 1, my A is Y, my S2 is 4. So now I got Y squared equals 4, so Y is 2. So these are my two values that I can find for problem 24. In problem 25, I have the same situation. Now I'm going to be finding 3 different values in problem 25. I'm going to find X first, and we'll stay with green for finding X. So I'm going to find X first. This is leg 1. Okay, so I've got leg 1, H, and remember 10 minus 3 is 7. That's my S1. So I've got H, L1, L1, S1. H is 10. L1 is is 7. S1, excuse me, L1 is X, excuse me, S1 is 7. So I got 10 to X, X to 7, so I got X squared equals 70, and X is equal to the square root of 70. And 70 does not have any perfect square factors in it. So I've got to know that that's what my answer will be. Now I'm going to move this stuff up so I can get it out of my way. So I can have this stuff up where it was. And bring this up. I got my leg and my other leg here. Okay, now my next one is finding y. And in finding y, that's my blue, find y, I have S1, A, S2 here because of where y is positioned. It's in altitude, and I have S1 and S2. So now S1 is 7, y equals y 3, so y squared is equal to 21, y is equal to the square root of 21. Please notice I'm not finding the decimal value of these answers. Okay, I'm finding their exact roots, and the factors of 70 are 7, 2, and 5, so I can't extract any perfect roots there. And now my last one is finding z. So when I find z, that's L2. So that's H, L2, L2, S2, and here's S2. This is L2, and here's H. So I've got 10, L2 is Z, and I got Z again, and then my S2 is 3, so I got Z squared is equal to 30, and Z is equal to the square root of 30. Okay, so those are my three values for 25. Moving on. I got the same type, and again, I'm thinking in my head about this pattern where I got the and L1, those are legs, L2, that's a leg, S1, segment of the hypotenuse, S2, segment of the hypotenuse, A and H goes the whole length of the hypotenuse. And again, S1, A, S2, and then I have H, L1, L1, S1, and H, L2, L2, S2. So those are my plays with that formation. And I'm going to find three things again in 26. So again, finding X. And I'm going to go over my stuff and I'm going to minimize it, but finding X. Since X is this L2, now this is L2, L1, H is out here. This is S1, S2. So now I'm going to plug in the fact I've got H, L2, L2, S2, and H is 169, that's 144 plus 25. L2 is X, and S2 is 25. Now one of the nice things about this is X squared is equal to 25 times 169. Now I'm doing it this way because they are both perfect squares. If I take the square root of everything, X is equal to 5 times 13, and that is X is equal to 65. So that's a perfect square. Now when I'm finding Y is the altitude, and I have S1, A, S2, and S1's 144, that's a perfect square, A is Y. S2 is a perfect square at 25. So I'm really finding when I multiply two perfect squares together, I get a larger perfect square. So I'm going to use that to my advantage, multiply these together, take their square root, and find out the square root of 25 is 5, the square root of 144 is 12. So this becomes 5 times 12, which just is equal to 60. Okay, when I'm finding Z for problem 26, remember this is all for problem 26, finding Z, I've got that, that's L1, and I've got H, L1, L1, S1. So H is 169, L1 is Z, and S1 is 144. And again, I am multiplying two perfect squares together. They are perfect squares, and they just make me make a larger perfect square. So Z is equal to 13 times 12, and 13 times 12 will become, if I pop this in a calculator, 186. So we're just going to make sure that that's the case. 13 times 12. It's 156, excuse me, not 186. So this is 156. And that is my Z value. Okay, so now we're going to minimize these, so we can get to our next problem. And that's in 27, and the same stuff's going to get used. So X again is L2 in this case, so finding X. I've got H, L2, L2, S2. H is 5 plus 4, which is 9. L2 is X. S2 is 4, so I got X squared equal 36, so X is equal to 6 after I take the square root of both sides. Finding Y, I've got this as an altitude, so finding my altitude has me at S1A, A, S2, so S1 is 5, A is Y, and 4 is S2, so now I've got 20. Y squared is equal to 20, but that is 4 times 5, and 4 is the perfect square in that group when I take the square root, so Y is equal to 2 the square root of 5. Finding Z, which is L1, has me H, L1, L1, S1. So H is 9, L1 is Z. Z is equal to L1 again, so S1 is 5. So this is Z squared is equal to 45, but that's 9 times 5, and I take the square roots of those, and Z is equal to 3 the square root of 5. Again, we're going to minimize these. Now, keep in mind, you're checking your work on these, and whatever is going on, we should be very comfortable with these. If you have any questions, please ask. This next one is section 7.5, and we're using the side splitter and angle bisector theorems. Side splitter is problem 28, and side splitter basically states 12 is to 5 as X is to 6. So I cross multiply and I get 12 times 6 is 60, 72. That equals 5X. I divide by 5 and find out that 5 goes into 72 14.4 times for my answer. And I'm just going to double check that. Or I could just say 72 divided by 5. So it's 14.4. Okay, so that's my X. And I get to move on, and we'll just slide this up and keep that in that area. Let's see what we got going here. Make sure 12 is 72, 5 divided by 5. Yep, okay. Now in this next one, I've got an angle bisector, and the angle bisector states that these are proportional and these are proportional. Okay, I can set it up as X is to 9 and equals 13 is to 10. Things that are on the same side are on the top. Okay, so I could go 10X is equal to 9 times 13, which is 117. Dividing by 10, I get 11.7. Another way to set that very same problem up would be x is to 13 and 9 is to 10, where I use the means exchange property, and I got 10x is equal to 117, and x is still 11.7. Remember, the equivalent statements when their cross product is the same. Now in problem 10, or 30, excuse me, I'm going to group these and get that out of the way. Problem 30, I'm looking at side splitter again. Okay, so I've got x is to 40 as 21 is to 2.1x. So I've got 2.1x squared is equal to 40 times 21, 40 times 21, which equals 840. Okay, now I'm going to divide 840 by 2.1. Divided by 2.1 gives me 400. So x squared is equal to 400. I take the square root of both sides, and x is 20. So that's my answer. Here, sides angle bisector theorem again, where x is the 16. Okay, these guys are together, and then 7 is to, remember, I did x, so 7. 7 is to 6, and 7 times 16 is 112. I got 112 is to 7x, and I divide that by 6, and I know it's 18.6, or 18 2/3. Okay, but if I go 112, if I leave it as a fraction, I go 56 thirds. I could have said 56 thirds, that is equal to x. So any one of those answers can help me. In 32, I'm looking at 12. This is called side splitter, where these are parallel. So 12 is to 14 is equal to 9 is to x. 12, and I'm going to show you a trick on this one just because I haven't yet. 12 and 14, as I divide them, I can actually reduce those to be 6/7, and that's still the same relationship. So now 6x is equal to 7 times 9, which is 63. If I'm looking that over, okay, so that's 63, and I divide by 6, and I get 10.5. That actually goes pretty quick when I do it that way. In this next side splitter, see this opening that's 17.5? This opening is 14, and I can put that up there. I don't know why it came out the way it did, that L4. This opening is 14, because that's 6 plus 8. This is 17.5. So I'm looking at this, the whole length is 14, okay, the whole length is 17.5, and they should be equal. 14 is to 8, and that's to x, and people wonder, why did I choose 8? And it wasn't that I chose it, it's right here. 8 and x are opposite each other, and 14 and 17.5 are opposite each other. So now I got 14x is equal to 8 times 17.5. which is 140. So x is equal to 10 when I get that one done. I'm going to slide that up. We'll group that up a little bit, make that smaller, and we'll get to this last problem. Now, in this last problem, it's a word problem. We're going to group this one as well, get it out of the way. Now, the figure below shows the locations of a high school, a computer store, a library, and a convenience store. The street along which the computer store and library are located bisects the obtuse angle formed by the two of the other streets. So this is angle bisector. Use information in the figure to find the distance from the library to the convention center. So if I'm talking about the library to convention center, I'm looking for x. Now, this is angle bisector, and I can set it up the way it sits. I've got 3 to 4 is equal to x to 6. So I've got 18 is equal to 4x. I divide by 4 and find out that I have 4.5 is equal to x for my final answer. So 4.5, and what's that mean is the distance from the library to the convention center is 4.5 miles. Okay, I hope you're understanding these. I hope it went well. Good luck on your test, and we'll see you in class.